In today's digital world, data is king. Every click, transaction, and interaction generates data that can be analyzed to gain insights and drive decisions. Businesses and organizations rely on vast amounts of information stored in databases. These databases are the backbone of modern enterprises, enabling everything from customer relationship management to financial transactions. Structured query language, or SQL, is the language we use to communicate with these databases. It is a powerful tool that allows us to interact with the data stored within these systems. SQL allows us to store, retrieve, and manipulate data efficiently. Whether you need to update a single record or generate complex reports, SQL provides the commands to get the job done. Mastering SQL is essential for anyone working with data, from analysts to developers. It is a fundamental skill that opens up a world of possibilities in data analysis, software development, and beyond. Think of a database as a well-organized collection of information. Just like a library categorizes books into sections and shelves, a database organizes data into tables and columns. This information is organized into tables, with each table representing a different entity. These tables are related to each other through keys, creating a structured and interconnected data environment. For example, a customer table might store information about your customers, such as their names, email addresses, and phone numbers. This table acts as a central repository for all customer-related data, while an orders table might store information about their orders. This could include details like order IDs, products purchased, and quantities. By linking these tables, you can easily track which customers made which orders, providing valuable insights into purchasing behavior and trends. Understanding how to design and query these tables effectively is crucial for optimizing database performance and ensuring data integrity. SQL provides a range of commands and functions to help you achieve this, from basic select statements to advanced join operations. As you delve deeper into SQL, you'll discover its versatility and power. Whether you're building a simple application or managing a complex data warehouse, SQL is the key to unlocking the full potential of your data. In the next chapters, we'll explore the fundamental concepts of SQL, starting with basic queries and gradually moving to more advanced topics. By the end of this journey, you'll have a solid understanding of how to harness the power of SQL to manage and analyze data effectively. So, let's get started on this exciting journey into the world of SQL databases. Your path to becoming a data expert begins here. Before diving into the specifics of SQL queries, it's crucial to understand the concept of a database schema. A schema is like a blueprint that defines the structure of your database. It outlines the tables, the columns within each table, and the relationships between them. Imagine you're building a house. You wouldn't just start laying bricks without a plan, would you? Similarly, a database schema provides the plan for your database, ensuring that data is stored in a logical and organized manner. Now let's talk about relationships between tables. In a relational database, tables are often connected. For instance, in our customer and orders example, there's a clear link. A customer can place multiple orders. This link is established using foreign keys. A foreign key is a column in one table that references the primary key of another table. The primary key is a unique identifier for each row in a table. By using foreign keys, we create a link, ensuring that data integrity is maintained. Let's say our customers table has a primary key called customer ID. This primary key uniquely identifies each customer in our database. It's like a unique identifier or a social security number for each customer. No two customers can have the same customer ID, ensuring that each entry in the customers table is distinct and easily retrievable. Now, let's consider our orders table. This table records every order placed by customers. To link each order to the customer who placed it, we use a foreign key, also named customer ID. This foreign key in the orders table references the primary key in the customers table. By doing this, we establish a relationship between the two tables, ensuring that each order can be traced back to the customer who made it. This relationship is incredibly powerful. It allows us to perform complex queries with ease. For instance, if we want to retrieve all orders placed by a specific customer, we can simply join the customers and orders tables on the customer ID. This way, we can pull up all relevant orders for that customer in a matter of seconds, making data retrieval efficient and straightforward. Think of it like this. The foreign key is a bit like a tag on a suitcase. Just as a tag helps identify your suitcase among many others, a foreign key helps identify and link related data across different tables. The tag has your name on it, and it's attached to your suitcase. This ensures that even if your suitcase gets mixed up with others, you can still identify it because of the tag. Similarly, the foreign key in the orders table has the customer ID, which links it back to the corresponding customer in the customers table. This way, even if your suitcase gets mixed up with others, you can easily identify it because of the tag. In the same manner, even if there are thousands of orders in the orders table, the foreign key ensures that each order can be accurately linked to the correct customer. This not only helps in maintaining data integrity, but also makes data management and retrieval much more efficient. Querying data across tables. One of the most powerful features of SQL is the ability to query data across multiple tables. This is where joins come in. Joins allow us to combine data from different tables based on the relationships between them. Imagine you have a puzzle with two pieces. Each piece represents a table in your database. Joins are like the connecting parts of the puzzle pieces that allow you to put them together and see the complete picture. Select statements and joins. In this section, we will delve into the fundamental concepts of SQL select statements and the various types of joins that are essential for database management and data retrieval. To perform a join, we use the SQL select statement along with the join clause. The select statement is the cornerstone of SQL queries, allowing us to specify the exact data we want to retrieve from one or more tables in a database. By combining it with the join clause, we can merge data from multiple tables based on related columns. The select statement is used to retrieve data from a database, and the join clause specifies how to combine the data from different tables. This combination is powerful because it enables us to create complex queries that can pull together related information from various sources, providing a comprehensive view of the data. There are different types of joins, each serving a specific purpose. Understanding these types is crucial for effective database management. The most common types of joins include inner join, left join, right join, and full outer join. Each type of join has its own unique way of combining data, which can be used depending on the specific requirements of the query. For example, an inner join returns only the rows that have matching values in both tables, ensuring that the result set contains only the intersecting data. On the other hand, a left join returns all rows from the left table and the matching rows from the right table. If there is no match, the result is null on the side of the right table. This is particularly useful when we need to include all records from one table, regardless of whether there is a corresponding match in the other table. Understanding these joins and how to use them effectively can greatly enhance your ability to work with relational databases and perform complex data analysis. A worked example of joining tables. Let's say we want to retrieve a list of all orders along with the names of the customers who placed them. We can achieve this using the following SQL query: select customers, customer name, orders, order ID from customers, inner join orders on customers, customer ID equals orders, customer ID. This query selects the customer name from the customers table and the order ID from the orders table. The inner join clause combines the tables based on the condition that the customer ID in both tables must match. Mastering SQL relationships. practice makes perfect. The more you experiment with SQL queries and joins, the more confident you'll become in navigating the world of relational databases. Additional resources for SQL learning. If you're eager to delve deeper into the world of SQL, there are numerous resources available online and offline. Consider exploring online tutorials, taking SQL courses, or reading books like SQL in 10 Minutes to further enhance your skills.
Want to rise to your full potential in your studies and revise like a boss? You can trust Study Guide today to have you covered. Subscribe to this channel and see our website linked in the description of this video to see revision articles to maximize your study gains.